Hi everybody, this is Team 8 of Kim Hui-won, Lee Nam-hoon, Choa La, and Justin Chan, presenting the Haydar Aliyev Center. Last week, we introduced the design to production process of a panel used in irregular shaped buildings such as the Haydar Aliyev Center. To summarize the contents from last week, the first step begins with the 3D model of the panel through CAD. The next step after the model is the panel production process. In particular, this is a process of producing free-formed shaped panels that are often used for irregular shaped buildings. During this stage, a study is performed on the optimization of the panel production process in order to decrease the operational complexity and cost associated with different panel geometries. Lastly, the panel production is completed by pouring the concrete and fiber mixes into the mold. After the manufacturing process of the panels are complete, it can be transported to the construction site of the Haydar Aliyev Center. For today's presentation, we will focus on 1. How to transport the panels, 2. How to lift the panels, and 3. How to fix the panels. This will cover the entire process of turning the produced panel into a part of the building facade. Starting with how to transport a panel from the factory to the site. First, let's take a look at the process flow diagram of a panel. Here, you can see that the beginning of the raw materials in panel assembly was what we just covered in the summary of the past presentation. Next, we focused on the process of reaching the construction site after the panel assembly. The panels for the Haydar Aliyev Center are not manufactured in Azerbaijan due to the lack of resources and equipment for local manufacture. Instead, they are manufactured in Istanbul, Turkey. Because of this, all 17,000 panels must be imported to the site locally by some means of transportation. The panels must travel 1,500 miles or 2,400 kilometers to reach Azerbaijan from Istanbul. To accomplish this task, contractors use diesel trucks to ship the panels onto the site. The reason that they opted for trucks instead of trains or boats are unknown, but is most likely due to logistical complications and ease of operations. Next, we will be discussing about how the panels can be lifted onto the building. Before starting, let me introduce each panel's weight information. These values are the approximate weight of the general glass fiber reinforced panel by applying the total area of the building facade, the number and the size of the panels used. The average weight of GFRP and GFRC panels are 415 kilograms and 456 kilograms each. Because of all the production information associated with the exterior panels are generated, they could be manufactured, then shipped to the site by installation of local workers. On site, each panel is lifted by crane, then negotiated into position by hand. It is possible due to the product's light weight. General design, which was used to optimize the panel of the building, is said to be studied as a construction strategy such as optimizing the crane location. Lastly, we will be talking about how the panels are fastened onto the space frame. We conducted a study of the answer through a documentary of the building and a structural analysis of GFRP panels. Before I talk about how to fix the panels, I'll talk about the substructure of the panels. The structure and the panel are separated into 2 layers each. On the right, you can see that the primary structure is a steel space frame at the bottom of the assembly. Above that is the insulation layer, which is considered the first layer of the panel. Next is the secondary structure known as the panel frame with fastening points. And lastly, the GFRP panel sits on top of the last layer of the assembly. This order is the order of how the panels are laid onto the building. This is the process of lifting the panel to the top of the building through a crane. This panel is about 300 kilograms, which is one of the lightest panels used in the facade. Let's take a look at the details of the panel. We focus on the substructure of the panel, especially the purlin, which are the folds in the model on the right, and the ring-type bolt bracket that is seen at the 4 corners of the model. The first layer is a prefabricated weatherproofing tray system. It rests on the top chords of the space frame. This video gives you a closer look at the panels. It is important to note the joint part of the space frame. The node of the frame is a Miro-KK spherical node with a total of 16 holes. It enables the production of various geometries by having flexibility in the mounting angle. In the model shown to the right, a steel plate with bolts can be positioned facing outward of the surface in different configurations. Although the building cladding was specifically manufactured, no special fastener systems were required. They used standard bolts and screws, standard drill anchor systems for the concrete, and so on. After about 4,000 metal deck roof trays are completed, they installed the GRFP panels with the secondary structures. The white solid skin is an open joint rain screen cladding system, which required a secondary steel substructure to fix into the space frame. The secondary steel structure is attached to the nodes of the space frame by means of rods. It spans between the nodes and between the first layer of tubes to carry the actual panel fixings. The connection between the secondary steel and GRFP panels are connected by the joint shown on the right. It enables to accommodate tolerances between the secondary substructure and the panels above and below. This is the unit information of the substructure of GFRP open jointed rain screen. Some important details to note are the use of bolts as the primary method of fastening every component. In addition, each system has about 10 components. About 17,000 panels are fixed directly at site by human hands. This completes the panel installation. Lastly, the node substructure of the space frame that I mentioned before is as follows. This allows for a variety of frame structures to be built from various configurations allowed on the nodes. Here's a preview on next week's topic about the space frame, which is the main structure that enables construction of a freeform structure. Space frame is a three-dimensional truss, based on the rigidity of the triangle and composed of linear elements subject only to compression or tension. Space frame can be comprised of single-layer grids and double-layer grids. In the Haydar Aliyev Center, double-layer grids are chosen for its formation. Double-layer grids consist of two planar networks of members forming the top and bottom layers, parallel to each other and interconnected by vertical and oblique angled web members. As the influence of bending or torsional moment is insignificant, it is commonly used for the realization of fluctuating facades. All in all, the design of panels to the manufacturing, transportation, and construction processes are complete. From now on, we will study the design process to the construction process of the space frame structure that supports the building facade. This is the end of our presentation. Thank you.